So we have learned several methods for solving systems of equations. In the very beginning of this unit, we learned about graphs and tables. So I'm going to color that one green. And then we also learned how to do substitution these last few days. That's what we've been doing in class with the orange and blue cards. So I'll color that one orange. And we also learned elimination. Remember, elimination is the one where the letters are going to eliminate or cancel out. And we also learned matrix. And elimination and matrix came from the same kind of problem. We just used matrix whenever things didn't cancel out easily. So if we're looking at these examples here, we're trying to decide, hey, which one is set up for like that substitution problem, which one is set up for elimination, and which one is set up to do like a graph or a table with. So remember with elimination, we could find two, like the x's and y's were lined up, and you could find two inverse coefficients that would cancel out in your problem. So like in this problem right here, we notice that x and y are on the same side of the equal sign, and they're lined up so that we could cancel out the y's. So our method here that we would use is elimination, and we would say the two equations, or the two we're going to say equations because we have to, are in, remember what form this is, ax plus by equals c, so they're in standard form, and one variable will easily cancel. Okay. On number 2, we notice that this equation is in standard form, but this equation says y equals. So what method did we use for that? Substitution. And our reason is one equation says y equals. In number 3, both equations are in the form of y equals mx plus b. So we're going to say both equations are in y equals mx plus b form. And so because of that, it's easy to push that y equals button on your calculator, or to graph them, or to make a table. So this would be graphs and tables. Okay? All right, and if we're playing process of elimination, we've used all of them except for matrix, so I bet this one's going to be matrix, but let's check and see. Excuse me. So they're both lined up in standard form with ax plus by equals c, which is great, but nothing is going to cancel out here. Now, remember, I could just multiply this top equation by -3, and then one of these x's or y's would, well, actually both of them would cancel out in this problem. So then we would have a no solution type equation. So here we're just going to say this one is matrix, and then the reason is they are both ax plus by equals c, but nothing cancels. Okay, so they're both in ax plus by equals c form, but nothing is canceling out. Okay? All right, so number 1 says, which method would you use to solve this system of equations? And then it says, use that method to solve this system. So here are our options, like we were talking about up here. So we've got one equation says y equals, and one equation says 4x plus 2y equals 14. So I would guess that you guys would want to use substitution for this method, because one equation says y equals. So remember for this one, that we have, this one's going to be the orange, and this one's going to be the blue. And remember, we're going to change out a specific letter. Since it says y equals, we're going to put 2x plus 3 instead of y in this equation. So our new equation is 4x plus 2 parentheses 2x plus 3 equals 14. And then we're going to go solve it from there. What's the first thing we would do? Distribute. So we're going to distribute. 2 times 2x is 4x. 2 times 3 is 6. 4x plus 4x equals, or plus 6 equals 14. And then we're going to combine like terms. So 8x plus 6 equals 14. And then we're going to subtract 6. So 8x equals 14 minus 6 is 8. And then we'll divide both sides by 8. So we get x equals 1. Now remember, for a system, we're not finished solving when we get to the x equals 1 part. We actually have to go put that back into the substitute equation. So we'll pick our favorite equation, which is this y equals, because it's already solved for y. And we're going to say 2 parentheses 1 instead of 2x plus 3. And then 2 times 1 is 2, plus 3 is 5. So now we can write our ordered pair. Remember, x goes in the x spot, y goes in the y spot, so it's 1, 5. And we're done. Okay? All right. Number 2, which statement or statements best describes what you solved in this system of equation? Check all that apply. So we're applying it to number 1, and we're saying we got this answer 1, 5. Which one of these statements matches? So it says the answer includes 1 value for x and 1 value for y. That is true. We got x is 1, y is 5. So that is true. Both x and y canceled out in the equation, leaving only constants. That is not true. The constants made a false equation like 0 equals 12. Not true. The constants made a true equation like 0 equals 0 or 18 equals 18. That is also not true. Now let's take a look at when we graph these equations. The first one is solved for us. It says y equals 2x plus 3. So I know that m equals 2 and b equals 3. So I will begin at 3, and I'm going to go 2 up and 1 to the right. And then I'm going to draw my straight line. Please try to use a straight edge if you have one. I'm just being lazy right now, sorry. Now we're going to graph the second equation. The second equation is 4x plus 2y equals 14. In order to graph that equation, we must first make it say y equals. So to do that, we'll minus 4x. We've been practicing this in the warm-ups every day. And remember, we cannot combine 14 and 4x because they are not like terms. Then we'll divide everything by 2. We get y equals 7 minus 2x. So where do we start at? Start at 7. And this time we go down 2 and to the right 1. And then once I get my point of intersection, I usually just stop. Okay, so remember that the solution is right here. And notice how that solution is at 1, 5, which is what we got algebraically. Okay? So technically, we can actually use graphs to solve any system, right? As long as we can get them to say y equals, we can get them graphed. Or, you know, if we can get them to say point slope form, we could graph that too. All right, let's look at the next one. So the next one says 4x minus 2y equals negative 6, and then negative 2x plus 4y equals negative 2. These ones are set up to solve using which one of these 3 methods? And you look at them and you're like, oh, you know what? They're set up to solve using elimination or the matrix because they say ax plus by equals c. So real quick, I'm going to do the matrix on my calculator, clear it out, enter my numbers. So we've got 4, negative 2, negative 6, then negative 2. Remember, there's a 1 hiding right there. And then negative 2. Second quit. Second matrix. Math for ref. So it can go pretty fast if you use your calculator. So we got something weird here because we don't usually get a negative 0.5. So I'm going to go back and check, make sure I typed everything in correctly. So 4, -2, -6, -2, 1, and -2. I did. So I'm going to write down my matrix here, and we're going to explore graphically what's happening in this equation so that we can tell what we're going to write for the answer to this one. Because I know I typed everything in right and my matrix came out. It's supposed to be 1, 0, 0, 1 in these 4 places, and it's not. So that's weird, okay? So we'll just write weird. Okay, so let's take a look here at these equations. Is there a number I could have multiplied these equations by so that I could cancel something out? Yeah, I could multiply the bottom equation by 2, and that would cancel out my y's. Do y'all agree? So let's do that. If I multiply the bottom equation by 2, we get -4x, positive 2y, -4 on the other side. And then on top we have 4x minus 2y equals -6. So now we'll go do that elimination thing. Everything cancels, so I write 0. And then on this side I combine my 6 and my 4 and I get -10. So since the trick didn't work, we're going to have to do it like we did with the multiply by a number to try to cancel it out and see what's happening here. So when does 0 equal -10? It never does, so we say no solution. Okay, so we're going to look here. Does it include one value for x and for y? No. Did both the x and the y cancel out, leaving only constants? Yes. Did we get a false equation or a true equation? And what we just discovered was we got a false equation. Now we're going to graph these two equations on our grid. So to graph them, we need to solve them for y, or we could use the graphing by intercepts problem, which I think would be easier to do. So let's practice that for a second. I think it's, well, it's not, because when we do division here, but okay. Because when we do the division on this one, we get a decimal for our intercept, for our x-intercept. So let's actually solve them for y. The bottom equation is going to be easier to solve for y. I'm going to come over here to the top, I guess. So it's -2x plus y equals -2. So to solve that one, we just add 2x to both sides. So y equals -2 plus 2x. Then we're going to graph that equation. So we'll go to -2 on our graph. And then 2x means it goes, the plus 2x means we go up 2 and to the right 1. So there's my first line. And now let's solve the other equation for, for y. So we have 4x minus 2y equals -6. So first we subtract the x value, minus 4x. So -2y equals -6 minus 4x. And then we divide everything by -2. Sorry, it's in the words. We know what that says. So we get, I'll write it over here, y equals -6 divided by -2 is +3. And -4 divided by -2 is +2x. And we notice that we start at 3 and we go up 2 over 1. Now, that's the same exact slope I did on my last equation. So that means that these lines are parallel because they have the same slope. So we say parallel, so no solution. Sorry, I can't spell today. All right. Okay, one more problem set to do with you guys, and then you will be on your own. So this last one, we have it set up to do elimination if we want, or we could do substitution easily if we wanted to get the x all by itself, right? We could have done the same thing over here. We could have done substitution if we got the y by itself, but let's just go ahead and do elimination for this one because it's all set up and ready to go. We could do the matrix also, so let's check it with the matrix and see if we end up with a weird matrix again. sometimes we end up with a weird matrix. So we're going to type in 1, 2, 6, 3, 6, 18. We're going to do the little ref thing. Oh, did you see what I did? If you already had ref typed in, you could just push it again and it'll do it again on your matrix. So when we did that, we got this weird matrix again. And it was 1, 2, 6, 0, 0, 0. That is really weird. So let's take a look at what's going on in this problem. If I wanted to eliminate, I'm going to need to multiply one of these equations by a number that will cancel letters out. If I have 1 here, I can multiply by -3 to make them cancel. So -3 on the outside. So we get -3x, -6y, and then equals -18. And then on the bottom, we have 3x, +6y, and +18. So then I go through and I'm like, cancel, cancel. Whoa, everything canceled out. So we get 0 is equal to 0. Okay. So it says here the answer includes one value for x and one value of y. That's no. Both x and y canceled out, leaving only constants. That's no. Yes. And then the constants made a true equation. Oops, the box is missing. So this is, we would check this box right here, okay? So it's different than the one we did a minute ago because the one we did a minute ago was 0 equals -10, and we said that's no solution. Do you remember what we say when we get the same number on both sides? For this one, we're gonna say infinitely many solutions, okay? And let's see what that looks like as an actual line. So we're going to solve these equations for y so that we can graph them. So let's start with the first one. X plus 2y equals 6. Take away the x on both sides. 2y equals 6 minus x. Divide by 2 on both sides. Y equals 3. And then remember there's a 1 in front of the x there, so we have -1/2, the x falls off to the side. So that means I start at 3, and I'm going to go down 1 and to the right 2. Oh, that was a really bad drawing of a line. Grab a straight edge, it'll be better for you. Okay, and now we're going to graph this second line, so we'll rewrite it. I'm going to write it down here. So we have 3x plus 6y equals 18. First we minus 3x. And then we're going to divide by 6. So that's y equals 18 divided by 6 is 3. And then 3 over 6 is a fraction, so let's do that on our calculator. It's a half, oh sorry, it's a half, and it's negative. Wait a second, I'm going to start at 3, and I'm going to go down 1 to the right. Isn't that the same line if I start at 3 and I go down 1 to the right 2? Yeah, so these are the same line. So we say infinitely many solutions. Infinitely many solutions. And you'll notice in textbooks they abbreviate solutions SOLNS. Okay. All right. So that's it for today. Your job now is to do this practice. So we want you to pick a method to solve. And then please graph every single one of them. So always make graphs, but then if you could solve using elimination, go ahead and do that. For instance, on number 1, we could solve this one using elimination, so go ahead and solve that using elimination. Okay, so I'm expecting you to solve it the appropriate way. There's 3 on the front and 3 problems on the back. And that is your practice for the day, okay? And then we'll go over it again tomorrow and answer any questions that you may have, okay? Thank you so much for watching. Have a great day.